Sweet. All right. Sorry about that, everybody. Just getting everything set up. All right. Um, Welcome to this month's JaxLUG meeting. I'm Christian McLaughlin. I spoke at the last one, even though we didn't have one last month. Um, so I decided to go ahead and host this one. Um, a bit about myself, if you guys weren't there at the last meeting, I am a information security professional. I started my career off in the military. I was an aviation electrician's mate. Then I branched off a couple years ago and got into cybersecurity, where I joined one of the local companies in Jacksonville, working the blue team as a SOC analyst. Worked my way into the senior position, and then started working pen tests. And now I work with a different company doing pen testing full time. So I have worked both red team and blue team. I have been working on computers since I can remember. I've always been interested in networking and routing. I went to college for that, and I'm now finishing my degree in cybersecurity. But I always enjoy building and breaking systems. So this talk today is going to be about sharing is caring, IPFS, which stands for Interplanetary File System. I currently do not have implemented in my system IPFS, but I do have an extensive amount of knowledge and experience with web development. That includes designing back end, front end and back end servers, working on servers, hardware, and getting everything set up so that the website is viewable from your side. So this is something that I might be able to have a little bit more proficiency with talking about. Let's go ahead and get talking. So the internet as we know it right now, when you visit a website, you'll go onto the internet, or you'll Google it through. You'll Google through. You'll search through a search provider like Google, DuckDuckGo, Yahoo, if you still use that, or if you live in Russia, you'll use Yandex. Uh, you'll use those to search for websites, or if you know the website like Facebook.com, Google.com, Yahoo.com, you'll visit those websites directly. Now, when you visit these websites, what happens is that you aren't actually going to the website, you're going to the IP address, and you're requesting for the domain, and you're talking out to a domain server. The domain server says, you're saying, hey, do you know where this website's located? The domain server is like, sure, it's located at this IP address. It gives you the IP address. Then you navigate to that IP address over port 80. You get to that IP, you get to that server, and the server's like, hey, this is the content that I have. You throw it a GET request, and it will give you a response to that depending on what you are requesting. Normally, it's going to be for the web page. But if you're requesting other things like an FTP link, or if you are sending encrypted transmissions, I don't want to get into that, but you're going to send a GET request and you're going to get a response. So all of this is done through a very not fragile, but our system works until it doesn't work. And I'm sure you've experienced it where you've gone on the internet and a website doesn't work, or you want to log into your PlayStation and PlayStation Network is down. And you start noticing and Googling, you find out that half the internet is just down. And you find out that, oh, it's because of Cloudflare, or it's because of Akamai, or AWS is down, so it's causing literally a third of the internet to just be down. And this is what I consider a single point of failure. You also have single points of failure when you're talking about having a server, right, for a specific individual website, not just these larger companies or these larger organizations that host these websites, or not host them, but that they're hosting providers. So, but you have your individual site, your server, right? Like at my house, I have a web server at home, and if that web server goes down, my entire website's down. If my network is cut off, nobody can access my websites at home from the internet. So that is another single point of failure that we have here with the internet. So this is how the internet works today, and it just functions, and we accept it because that's how it is. We try to constantly improve it, but what we're doing is we're taking a system, a foundation that we've been working off of, and we're building on top of it. Instead of now that the internet's been out for decades, we have another system that we could possibly use to rebuild the entire internet off of, and that is called IPFS. But first, we're going to talk about Hypertext Transfer Protocol, because this is the exact, not really the competitor, but this is what we are dealing with right now versus IPFS. So Hypertext Transfer Protocol was developed in 1989, and it is exactly what I said. It is what the modern world connects on. When you go into when you go to a website, google.com, you're going to http://s :/ google.com, and you're gonna request for that IP address. Now, whether or not you put an HTTP or whatnot, the browser knows you're talking over the HTTP protocol, so it's going to make these requests over port 80 or 443, and it knows this for you because HTTP is built into our modern systems. It is built into Chrome and Firefox, so these systems know that we're talking over, and they'll make these requests automatically. And speaking of requests, when you're working working with HTTP, it's a request response type of transaction. The source, your computer, is making the request, and then the response is going to come back from the server. You see a lot of times you'll see 404, 503, 302. These are responses. Now those are not good responses. Normally, what you're looking for is a 200 response, which is going to be what is going to deliver the content to you, or a redirect through a 300 response. But that is what you're looking for. So there are multiple different versions. I guess I didn't finish HTTP3. HTTP3 has been implemented a couple of years ago, and it's not widely accepted or adopted. But HTTP2 was invented, or was pushed out in 2015, and it has been since adopted by a lot of major websites and web domains. So I guess the slide shows off a little bit. I wonder what could be wrong. Let's fix this real quick. I want everybody to be able to see this. Oh, I know exactly what's wrong. This has to do with my fault. I apologize for the technical delays or the technical problems. I'm not a professional streamer. I don't make my money off of YouTube or Twitch. Please forgive me. You guys get a sneak peek behind the scenes while I fix this. At least we haven't really gotten into anything too crazy yet. Cool. That should be better. I knew this because this happened last time. And they'll give me a heads up, let me know. Anyways, we'll get there one day. Cool. So we're going to talk about IPFS now. So that's HTTP. That's what we are used to. That's what we know. And IPFS is what is being used now, but not in a widely adopted manner. So IPFS was launched in 2015 with HTTP 2. And this is a peer-to-peer type of networking. So you can think of it exactly like torrenting, because that's peer-to-peer. Oh, if anybody's familiar with torrenting, what'll happen is you will have multiple different servers on the torrent network, and they will host a portion of the file. And what happens is when you request for this file, you are the leecher, and you are looking for seeders. So you'll say like a file has 10 seeders. They're seeding a 1 gigabyte file, and you're going to get this file from these multiple different servers that have the file that they're seeding. If you have more seeders, you have more speed and a better chance of getting it. But if you have minimal to no seeders, the file could take forever to download. So this is, and I don't want to get too deep into that because we'll talk about that later, but this is pretty much what it is. The web is with a peer-to-peer network versus the server host, the server and client network. You aren't just requesting to speak to one server located at this IP address, 8.8.8.8. You are now requesting to speak to whoever has the file, and whoever has it will respond. It could be whoever's closest, whoever has the file that's available to give it to you at that moment. And if that person drops off, somebody else will pick up. So that's pretty much how the peer-to-peer networking works. It's multiple people who are giving, or multiple servers who are giving that single client the data. This system is efficient, it's persistent, it's decentralized, and it's resilient. And we're going to talk about all of those in the coming slides. So here's a quick drill down chart of the differences between HTTP and IPFS. So like I said earlier, HTTP is centralized. Centralized meaning that you are making a specific request to a specific server. It doesn't even matter if you have load balancing implemented, right? Because load balancing is just a way for it to take that request to that server and to distribute it to multiple other servers behind that IP address, right? You are still making a request to a specific IP address. If that IP address for some reason goes down, if you have load balancing between multiple different IP addresses and multiple different sites and you have those spread out, yes, that's different, but it's still centralized. You're still making that request. There is still at some point a line being drawn from point A to point B, and if that line is cut, you're going to lose. You'll lose that connection. That server will be offline. We see all the time with these internet outages for these providers. Whereas decentralized, it's going out to multiple different peers. All you are saying is, hey, who has this file? And then the servers will respond, I have the file, let me give it to you. Requests use the address of the host, just like I said. You get the domain, it gives you the IP address, you make the request to the IP address. Whereas requests are made with a cryptographic hash. So the file, how you would request for the name of the file is you get the hash of the file, right? Or the website or whatever you're trying to access. So you take that file and you hash it. Now, if you aren't familiar with hashing, I will go over it really quickly. Think of hashing like a way that you give a file, or we'll say a file, an identifiable number that distinguishes it from every other file in the world. It's an alphanumerical number that cannot be duplicate with another file, with another number, meaning that no matter what, that file correlates to that hash and only that hash. Now, how do you get that hash? You take the contents of the file, you throw it in a hashing algorithm, and it spits out this hash. The hash could be 1632, depending on what type of hash it is, however long the length of the hash is, and that's what it's going to be. The longer the hash, the less duplication you have within, depending on the hashing algorithm that you use, like a SHA-256 or one fish, two fish. I hope I'm saying these right. Anyways, you're going to get a different result. The important thing is that you don't have any clashing, meaning that you take one file and you take another file and they both spit out the same hash. Now, whenever you see any collision going on, that hashing algorithm is considered no good anymore. So, anyways, that's for people that aren't familiar with hashing. It is a way to ensure the integrity of a file. And we'll talk about integrity later. So what you do is you say, I have this hash, and you request, who has the hash? Who has this hash? And you're going to get a response from a server that is hosting that hash, and they're going to give you that data. Versus saying, who is this? It's who has this. So if the server's down on HTTP, you can't access the data. Whereas on IPFS, the only way you're not going to be able to access the data is if all of the servers are down. So they all are going to have to be down, or they're all going to have to be unable to make that request. HTTP is low bandwidth versus IPFS, which is high bandwidth. Let me explain that. You're lower and higher is what I would say. So you're making multiple connections, right? Tons of people are making requests to Facebook.com, and Facebook.com is responding to all of those requests. Whereas in IPFS, you are making multiple people are making multiple requests to multiple different servers. Now, you do have technology that you can implement to balance out that load, to distribute that. But the important thing is these are like exceptions, right? So out of the box, HTTP works like this, but out of the box, IPFS works like this with minimal modification, with minimal implementation. It just works like this. The protocol, not your setup, not the system that you've engineered. It's the protocol itself. So when we're talking about one-to-one, yeah, I could implement. I could have a cluster of servers, right? But that's not how the protocol works. So that's what we're talking about: low bandwidth and high bandwidth. HTTP, another one, is hosting. I found this out through my project that I was building. My project was to build and host a website for $0 a month. Now, my building costs were probably in excess of being able to go to AWS and host my website for the next 10 years. But my monthly costs are zero, and that's the important thing. Also, I have more control over my hosting than I do if I host over somewhere else. Anyways, there is a cost involved with hosting. So if I wanted to host a website online, I would have to go to AWS, or I could host it on I could host it on a website like Squarespace or anywhere. Or DigitalOcean, but there's a monthly cost incurred for hosting that. Uh, Whereas IPFS uses nodes, and there's no cost involved with hosting it, because you're not a provider is not providing that service to you. Your data is being distributed to voluntary peers who are volunteering to host the data. Just like in a hosting site or a hosting network where you're torrenting data, right? I am holding the torrent files for all this data that I downloaded, and I am choosing to leave it up to see back out, right? That is the same thing right there. If you're seeding it, you are a node on that network versus you're not directly having an account where you are providing a client service to somebody who is signing up for your hosting service. HTTP, though, however, is a well established in the industry, whereas IPFS is new. Where HTTP came out in 1985, whatever I said before in the previous slide, IPFS came out in 2015. Was developed in 2015. Was not implemented into its next iteration. It was developed and pushed out. So that's pretty new in the computer world. So it's slowly being adopted. It is very sluggish. It's more popular in the underground, not really underground community, but the hobbyist community, I guess you could say. The people that like to operate on the internet is for sharing perspective, sharing data, sharing files, that internet free movement. IPFS is more popular there as a protocol versus HTTP, where people just want to get on TikTok, want to watch YouTube videos, want to get on Facebook. That's HTTP. And HTTP support, like I said earlier, is built into the browser, whereas IPFS, you either need an HTTP to IPFS protocol, or you need to set up IPFS manually on your system. And there's another way to use IPFS.io to get to these sites, but that's sort of the similar of using like a web proxy. But yeah, that's how it's an extra step now to access IPFS versus HTTP, which just works when you put it in a web browser. So the problems, like we talked earlier, services can go down, like Cloudflare, AWS, and Akamai. That's what causes HTTP to be not so reliable compared to IPFS. Restrictions by government. If a government like India, or I hate to call it governments, but this has happened in the past, where India cuts off the internet, where Turkey cuts off the internet, where Burma cuts off the internet, or cuts off access to Facebook or Instagram, or they don't want people to use Google. They're blocking access to the IP addresses. They know where the data is going to, so they block it right there. They block the destination. So you don't really know you can't block a host in IPFS, because the IPFS node is hosting a lot of data. And if you block that node, right, not only are you blocking the data that it could be distributing, but the other data that it's distributing, the legitimate or the approved data. And on top of that, to block just that node, you'd also need to block all of the other nodes that are supporting that data. Um, it's not nearly the same as trying to stop HTTP. It would be a massive. If you're talking about people that persistently want to push out data and want to get a message out, or they want to use the internet and weaponize it as an intelligence platform, these people are going to easily be able to move their operations from one node to another, and there's nothing you can do about it. Whereas HTTP, it's pretty easy to stop that and block that. So you can bypass government and country restrictions by using IPFS. And latency and download times, like we talked earlier with bandwidth, um, the way that, and again, you can make this work in HTTP, but with IPFS, it will try to contact the closest node. And since you have multiple nodes online, you have a higher availability of the data, and you could have the data could be closer to you, because if there's a node in your state or your local area, it's going to download from that closest node. Versus with HTTP, you're making a request to a server which is located in a static area. Yes, you could have your files hosted and have a forward cache posted. You could do these things, but the protocol itself, HTTP, doesn't work like that. We do these we engineer these add-ons and these additions to make the protocol work better. But HTTP does not function out of the box like that, just like IPFS does. So I thought I spelled security wrong. Talking about security and privacy, this is another important factor with IPFS. As we move into the future, these things are important to implement out of the box. When HTTP was first created, it was created as HTTP over port 80, plain text. You could intercept all that data. You could see everything that was happening online in plain text. So HTTP over SSL was created as the HTTPS protocol, which is over port 443, and we use that to communicate more securely online. So IPFS out of the box in 2015 needs to be secure, which means it needs to have the information confidentiality, information availability, and information integrity. So we're going to talk about that. Encryption for IPFS, there are two types of encryptions. So you have encryption for data at rest and for encryption for data in motion. IPFS encrypts data in motion, meaning when you're making a request and it's sending you the data is encrypted. Data at rest is not encrypted. And the reason for that is the encryption is up to you. You set the level of encryption. The node that's holding your data can view your data. So if you want to implement encryption, right, you implement that level of encryption that you want. The data is encrypted as it is being moved, or the request is being made, and then it is decrypted once it reaches the client, and then it is decrypted again if they have the key that they need. So encryption at rest is totally up to you. That provides a level of flexibility for those who want to set up their own encryption. You have a wide range of options now to choose from versus a specific option that is provided to you. But out of the box, people who are lazy and they don't want to implement that, don't choose to implement it, or just don't know to implement it, will not, and therefore that data is plain text. So yeah, that's not really a flaw. It's just that's how it is. So yeah, now you know. Hashing, though, like we talked before with the hashes, when you're looking for a file or a website, you are using the hash. So if somebody were to change or alter that file or that hash, and I'm talking a change so small like taking a lowercase I and turning it into a capital I, the entire hash will change. I'm talking about all 16, 20, 32 letters will all change. It'll be a completely different hash, even though you just changed one small thing about it. So this provides more integrity. You know that the information that you are requesting is what you are requesting. It is not some false fake version of it. So yeah, integrity is out of the box, just it's there. The whole entire protocol is based on the integrity, because the hash, getting to the file, is you have to use a hash. So, and decentralization, which minimizes downtime, that is availability. You are increasing your availability exponentially at the base level by using a peer-to-peer protocol such as IPFS. So your two biggest things, which is integrity and availability, are already taken care of, and confidentiality is one that just needs to be taken more care of. Versus if I were to set up a website on today, like I have to worry about all of those. I have to worry about, decentralized, like downtime. I have to worry, how can I make sure that my website can survive an attack? So I can create a cluster. I can also create caches. I can create backups, backup servers that can go down in the event that I have a failover and one server goes down. I can have another one online. I have to think about those things. I have to also think about tampering, right? That's a massive thing. I don't want people to plagiarize my website or to ruin the integrity of the website. So these are all things I have to think of. Versus IPFS, it just works automatically. That's how it works. There's no questions about it. Yeah, let's go to this now. So I pulled up, go away, oh, wrong one. Here, cool, all right. This is IPFS's website, so ipfs.io. Here you can download and install IPFS. It works on Windows, Linux, Mac, and everything else you can think of. I know this is a Linux user group meeting, but this is actually a technology that I have started to use on my Linux servers. And I think this is actually, since Linux users are most notably the ones that are worried about freeware and sharing information, and we operate on a premise of information is free to share to everyone, versus Windows and Mac, who are companies that try to monetize their technology. I felt like this is a more fitting subject for Linux. I'm trying to justify my conversation to Dan so that he understands why I picked this topic today. Um, so IPFS, this is the website. Another cool thing is you can access. This is another way I told you how to access IPFS websites. So, for example, Wikipedia has backed up their entire, not really backed up, but they have also created their entire website to be available on IPFS. So if I were to go to a Wikipedia page like Boba Fett, this is it right here on the website, on the interwebs, accessing it through HTTPS right here. It works out of the box. If I were to go to google.com, I'm going to go to google.com, but I'm actually going to http.google.com. So it works automatically out of the box. On the other hand, if I were to go to this one, which is the IPFS domain, this is the exact same thing. It doesn't look as pretty, but remember, I'm accessing it through their gateway. So, yeah. But this is the exact same thing. This is exactly the same. All the data is still here. Every single thing is the same. So, if I wanted to search here, I could search Boba Fett. And you have the website right here. It just works like google.com. Wikipedia is going to pull up first because, Wikipedia has all of their stuff backed up on here. So that's an example. Now, if you want to visit that website, right, click here. You would click this link, copy the link address. The link address is going to be, it's going to automatically include it for you, but this right here, that is the hash. That's the hash that I was talking about earlier. So if I were to take this and I were to go to ipfs.io /that, .html, and nope, let's take out the HTML. My IPFS.io, IPFS.io. Oh no. Nope. Oh, here it is. This is the HTML hash. So Boba Fett, HTML, Boba Fett, parent hash. Okay, here we go. This is what I'm looking for. That's the same thing. Well, oh, IPFS. Okay, I see what I did wrong. IPFS.io / IPFS / that .html. Let's take out the HTML. There we go. All right, I took out the HTML. So yeah, it's you're using the hash. So essentially, what I did, in case I went too fast, IPFS.io, which is the website, and then you're saying I'm getting an IP. I'm going to look for an IPFS web page, and then you're typing in the hash. That's the hash of the web page right there. So when you hit enter, you are requesting for that hash. Now, this website right here, while Wikipedia / Boba Fett is being hosted by somebody. I don't know who Wikipedia's hosting provider is. I'm hoping it would say it on here somewhere. Wikipedia is being hosted by somebody. It's being hosted on a server somewhere. Oh, here you go. MediaWiki. And MediaWiki is being hosted by something else. Whatever. Not important. Either the important thing is that it is being hosted on a server somewhere, and go away. And whereas this data that I accessed right here is being hosted by a node. So somebody on it could be somebody on their laptop. It could be somebody with a server that they built at home. It could be on a Raspberry Pi. But this data is being held somewhere, and I accessed it on the closest node because I requested for this hash right here. There are IPFS browsers. There's ways to implement HTTP to IPFS protocols with extensions. But the important thing to know is that IPFS does not work out of the box. You do have to work around, do like a small workaround to get to it. And let me delete some of these. So this is their document page right here. Let's go over this really quickly. I'm not here to read through a doc page with you guys, but I do want to show you some important things though. On here, we already talked about decentralization and content addressing. Content addressing is pretty much that. It's pretty much saying that this is how you communicate. You're okay. That's why I needed the wiki and the link with HTML. Okay, but I made the request to the hash. So content addressing through HTTP uses a traditional URL. A URL is the protocol, / the domain, the TLD of the domain, so .com, .org, whatever. Then you have the subdirectory. You'll have a file. You'll have and you go on and on. Like here you have a PowerPoint file. Here's a document file. This is a Wikipedia page for aardvark. But this is it uses a URL, whereas IPFS uses a hash, and it's just saying, hey, who has this? Give it to me. And we'll talk about that stuff later, how IPFS works. None of this stuff is, you can read through this if you guys want to, but none of this is super interesting for this talk. Privacy encryption we already talked about. Content identifiers for hashing, no identification, privacy, controlling what you share using public gateways, Tor, encryption. We already talked about encryption. This is showing that the data is encrypted in transit, but not necessarily on the server itself. It gets locked when it's going this way, and it gets unlocked once it gets to the requester. Yes. So cool. Yeah, we didn't pull most of my stuff from there anyways. So more about hashing. So hashing itself, again, is a very important central part of IPFS. I've mentioned it multiple times. The fact that IPFS is built around hashing automatically gives the protocol a great deal of benefits. So some more things about hashing outside of security, or really related to security still, I guess, is it prevents deduplication. So deduplication would mean that you have two things that look exactly the same, but there might be a small distinct difference between the two. Like I said, you'll have one made with a lowercase I and one with a capital I. They'll have completely different hashes. They won't even look the same. It's not like when you go on Google.com and you go on Google.com spelled with three O's. It is not the same thing at all. Absolutely not the same thing. So the hash gets you to to that one place, and you can't really control what your hash looks like. So it's not like you can really print out exactly what. So you can't copy a hash and then change one letter on it. It's going to take you completely somewhere different. Um, the other thing with hashing and how the system works, like kind of like blockchain a little bit, is that the data is immutable. You can't delete or alter the data out there. Now, that might seem kind of weird, like why I can't change my website or my file. What if I want to use IPFS to host a spreadsheet and I want to have a collaborative group working on the spreadsheet? I can't change it. I can't alter it. That'd be pointless. What's the point of that then? Now I'm just creating static websites and then hoping I finished it and push it out to production. So that's not exactly how it works. IPFS uses versioning, meaning that you have the original file. Actually, you know what? I just showed you guys earlier in the IPFS search right here. Versioning, right? Or these are parent hashes. There should be a way to see IPFS versions. I'm not gonna look for it. I should have had it pulled up, or I should have had it pulled up before or not. Anyways, so what it's saying is that it's similar, like working on a file on GitHub, or if you are used to using Docker or anything really that's collaborative, you'll have a parent or the original image, and then as you create new versions, you will say, hey, this is the updated version of this 1.1.1, 1.1.2, 1.1.3. You go to 1.1.2, 1.2.1, 1.2.0. For whatever, as it's being updated, the versions are increasing, so you can refer back to older versions, right? And you can see where changes are being made. So files aren't being altered in the sense that my spreadsheet or my spreadsheet dot CSV, right, is being saved over and over again, and that same file name is just having the data updated. And then once I save that file, the old data is gone forever. You are just creating a new file with a new version to be uploaded. So it is actually the opposite of what you think as not being collaborative. It is highly collaborative. It is highly useful for making changes and tracking those changes too. So when I first heard about, IPFS is, immutable, what does that mean? Or not what does that mean, but like, why would I want to use that? And then I found out that was the case, how it uses versions. I was like, oh, that's actually way more useful than I thought it would be. So I know it's been a shortish talk. We're getting towards the end here. I really didn't have a whole lot of proof of concepts, or not really proof of concepts, but uh, any demos that I could do aside from just showing you navigating to that wiki page on IPFS, because I don't have the systems put up and built. I don't have anything built up. I don't host. I don't have a node hosting IPFS. Although after this, I do want to start implementing a node so that I can start contributing to the project. But at the time right now, I do not have any, and I did not feel like spooling anything up just for this presentation. So it is going to be a little bit shorter, probably be around, keep it an hour since we're getting to the end. But moving forward, where does IPFS fit into the future, right? You're talking about not just taking a system that we already have and building on top of it like HTTP is, but you're talking about a completely different system. In fact, the two systems are so far apart that the infrastructure would have to be, and I say infrastructure as in like not the physical hardware, but the way in which we connect would have to be completely changed. You would still keep computers connected. You'd still use routers and switches, and you still use IP addresses, and routing as it is known today would still exist. But how we host content on the internet, how we access web pages, how we share files, that's the thing that's completely different than how we do it now. That would have to be completely changed. Could we live in a world where both systems are adopted? Yeah, we live in a world where people torrent stuff all the time, where there's massive underground communities for sharing and distributing files. Linux shares ISO distributions on or ISOs through a distributed torrent network. Um, so IPFS is extremely relevant, depending on where you look. In the Linux community, very, very relevant. I actually, when I was requesting to find out what, or asking my teammates, what talk should I give, and one of my teammates was like IPFS, and I was like, that's funny because I was actually considering giving a talk on IPFS. I already have a deck built for IPFS. I might as well give it, and I have been considering implementing it at home too. So depending on who you're asking, they are going to know. If I ask my parents, who are not technically savvy, so some parents are, mine aren't, or if I were to ask my friends or anybody that I am close to that is not really computer savvy, IPFS versus HTTP, like, would you use IPFS? They're gonna be like, WTF? I don't know what that is. So acronyms. Yeah, so that's the important thing, is that while IPFS is very ambitious in what it wants to do, and it works very well, and if it was given more implementation, it would we would have a faster, more available, more secure internet. The internet, as we know now, would be so much better. It would be so efficient. You would just see data being moved at such an incredible rate and so efficiently. It's great, but we don't. It would mean everybody changing over, everybody doing not really learning something new, but it would just mean tossing the whole system aside. I don't think that's going to happen. We're going to live in a world where both coexist at the same time, and they're going to. I think what we want to see is people who use HTTP, like Wikipedia, also host their content on IPFS or with IPFS, I should say. And when we see that happening, you might see a gradual shift of people, starting with the more technologically savvy people, over to IPFS versus HTTP. That is where you'll have both of them being used at the same time, because they do offer their advantages and their disadvantages equally. So while IPFS isn't really a different experience for the user necessarily, you will have some nuances and different. If your average user knows what to look for in that URL bar, right, they might notice little different things, but on average they won't. So while that might be the case, the integration of IPFS into mainstream, it's probably just going to take a long time. It's like that efficient method of loading an airplane. It's just never going to happen. We just don't do it. So we cannot do it with this. We would live in a better world automatically, but it's just not going to happen. So here are the references that I used. If anybody has any questions, please feel free to reach out to me on LinkedIn. I didn't include my socials on here. But if you are if you want to reach out to me, you can. Christian McLaughlin on LinkedIn. If you're not part of the Jacksonville Linux user Discord, I would encourage you to join that Discord. That is one of the most active Discords out of most of the Jacksonville groups. And not only that, but they are extremely helpful if you are just learning how to use Linux, if you are an average Linux user, or you want to take the next step to become more advanced, or you want to learn how to use Linux for work, that is a great place to start. You could use Reddit forums, you could watch YouTube videos, which are great, but plugging a question or needing help in that group, you're probably gonna get somebody who will want to help you more efficiently, but also you are going to start connecting and talking to some of the most awesome people that I know. You never know what your weekend might be like. You might be on there talking about Linux one day, and then you're gonna go help your friend uh, rebuild or do all kinds of stuff with his servers at the um, at the server farm. I'm talking about Michael, but you never know what you're gonna do if you plug yourself into that group. These guys are great. If you ever have any questions about Linux, please, by all means, join the Discord, attend monthly meetings. Um, but yeah, this is a quick talk for today about IPFS. Maybe in the future we can go over something differently, or we can add on to IPFS, I should say, and talk about something else about it. And maybe we might move JaxLUG over to IPFS. I don't know. We'll see. But um, but yeah, so I hope everybody has a good night. I will see you all next month with hopefully a different speaker. I'm hoping, and depending on the speaker, maybe a more advanced, hands-on topic than just going over IPFS slideshows. So hope everybody has a good weekend.